Hello, viewers. Today I will take you to a realm of sedimentary rocks, the rocks which were formed by a process called sedimentation. The title of my talk will be The Formation of Sedimentary Rocks. I give you an outline what I am going to cover in this session. What is a sediment? What is a sedimentary rock? Distribution in space and time. The types of sedimentary rocks, how sedimentary rocks are studied, the erosion, transport, deposition, interpretation of deposition environment, the mineral deposits in sedimentary rocks, and then I will summarize the entire talk. To introducing the subject, I say the sediments can be defined as loose solid particles originating from breaking apart of older pre-existing rocks by weathering and erosion. They are therefore called terrigenous. The word terrigenous has come from terra. Terra means earth and derived from the earth is called terrigenous. And is also called clastic. Both terminology exist in the geological literature. The clastic rocks form by accumulating particles of older rocks as class or mineral veins, including sand, gravel, and mud. On the other hand, non-clastic sedimentary rocks formed by chemical reactions, precipitation of dissolved components in the water, or with the help of organic activity and the preservation of organic matter in the sedimentary record. That is the basic information is that all over the world, the sedimentary rock cover about 75% of the surface area of land. Their study reveals the provenance, transportation, and deposition environment in mountains, modern and ancient shorelines, riverbeds, deserts, and swamps. With these basic information, we go to next one that these sedimentary rocks are repositories of hydrocarbons like the oil and coal. Also the ores of iron, aluminum, phosphate, potash, salt, lead, and zinc. And these sediments provide clues to ancient environment, the way the rocks were formed in specific type of environment. It also tells us about the paleoclimate. It also gives you idea about how the lands were predisposed during the during the later period of Earth history. That means we understand the paleogeography, and we also understand the evolution of organism through time. Formation of sedimentary rock involves four different processes. First is the weathering, that means breakdown of the pre-existing rock, pre-existing metamorphic rock or igneous rock or pre-existing sedimentary rock by weathering and breakdown of the material. They are eroded, and then they are transported, and finally they come to rest in some depositional bodies, depositional surfaces, which we call the depositional bases. This is a cartoon which shows you what I have just told you. The high up in the mountain, the source area is in the mountain. When it comes down by gravity, all sediments come by gravity with the help of either glaciers or the help of water. They either form alluvial fans in the mountains, or if they are in the moving water, then they form fluvial deposits. There are some lakes which form in the nearby area, or there may be some desertic area plain where your deposits are called aeolian. In the lake areas, they are called lacustrine, and the sediments which form on the riverbed or on the side of river are called fluvial rock. When they finally meet the sea, they form delta or they also form estuaries. Where they meet, then they meet the sea. There is a shallow zone where the sediments started forming, and we call shallow marine sedimentation. And as you go, and these rocks are called shelf sediments. As you go deeper down, then you have to go to marine deposits, deep marine deposits. Key features of these images are the sediment source area. The origin of sediment usually mountains of island. Alluvial fans are cone-shaped deposits formed where sediment-laden sediments streams spread out at the base of the mountain. Lacustrine are the sediments deposited in lakes. Aeolian is a wind-driven deposit, typically forming sand dunes. Explain it further. Fluvial are the river and stream deposits that transport sediments downstream. In the shore zone, they are called. There is a transitional area between the river and the sea, where the land meets the sea. Delta is a sedimentary deposit where a river meets a large body of water like a sea or lake. Or finally, it reaches the final marine area, the final deposition area, including deep sea and continental and shelf environment. Now, these sediments, once formed, they well formed, they are actually product of number first one is erosion. As I told you, first by weathering, then the erosion, and then transportation by wind, water, glacial, and gravity. And the material which is being carried in at the form of a sediment load are either in the form of a dissolved load or a suspended load or saltation load, and more commonly as bed load, what we call a traction wheel. Here's an example here, a river flowing like that, moving from left to right. This is carrying all the materials along with this. The finer material are being transported right toward the right, while the larger pebbles and boulders are left behind. This is how what we call it transportation of the sediment from origin to the depositional basin. On the other hand, the chemical rocks are formed by chemical weathering. The process is called carbonation and then leading to dissolution. There is a formula, there is an equation here. H2CO3 plus CO2 gives you H2CO3. CaCO3 with H2CO3 gives CaCO3 twice. And calcium carbonate with H2CO3 give you ionic calcium, and 2HCO3. On the other hand, there is another process which is formed through weathering, is by oxidation. Like in iron rocks, iron-rich rocks, where the oxygen combines with and form FeO3. The another form of chemical weathering is by hydrolysis. The common example of hydrolysis is the alteration of feldspar into clays in the granitic rocks. There is the equation of the feldspar. Now, most of the igneous rocks, whether it is igneous rock and metamorphic rock, contain feldspar, and they are the one which get dissolved fastest. With especially there are two type of feldspar: plagioclases and orthoclases. The plagioclases with carbonic acid and water, it gives rise to a clay mineral kaolinite. Similarly, orthoclase with carbonic acid and water also gives rise to kaolinite. Therefore, the ultimate result is the feldspar forms a clay mineral. There is one example here by which the granite rock becomes exfoliated. What is called exfoliation? Exfoliation means the layer by layer removal of granite layer, where the feldspars get dissolved and make the surface weak, and the material is removed from the top. So you have layers after layers which erodes the granite rock and forms big structure, big features like this, like which we find in mostly in the granitic terrain. In carbonate rocks, like one of the examples here, where the limestones are are dissolved, and by dissolution they form funny features, very interesting features, and sometimes they cover very large area. Some of the areas in the Southeast Asia where such type of features are very common. There is another example of dissolution of carbonate rocks, dissolution of carbonate rock, and formation of what we call a karst feature. Karst feature, this particular outcrop extends over about 300 square kilometer area. So you can see that this type of activity produces with carbonate rocks, and the dissolved carbonate rocks get deposited in another basin to produce some clay-rich carbonates. Now, to summarize it, the weathering products, you have got three major type of rock. I mean, among the igneous rock, the granite is the most common, and the second common is basalt. Granite gives rise to they contain feldspars, micas, quartz, and iron magnesium mineral. They produce clay minerals and hematite and goethite. Basalts contain feldspar and iron magnesium minerals. They also produce clay minerals, magnetite, hematite, goethite. Limestones, mainly the most important composition is calcite and also sometimes dolomite. There is no weathering product, but the material comes out in the ionic form of calcium, and the carbonate get dissolved and get deposited somewhere else where the conditions are conducive for deposition of carbonate rock. The biological weathering is another process by which the rock get informed. They produce digging. There are many organisms which dig on the sediment, and they what you cause bioturbation. It is also called pedoturbation. Pedoturbation means where by foot organism make a turbulence on the sediment, and the turbulence get disturbed. So it the main sedimentary process is gets disturbed. Now the action of mosses, lichens, algae, bacteria, etc. They also produce different type of rock, especially in carbonate rock. Burrowing is an example, very important. There are many organisms, especially on the coastal areas, or on the river banks, where the organisms burrow and live there. And in the process, they remove the material from the deeper part, and then they come out. Similarly, the root vegging. The roots, big trees have got very roots, and their roots keep disturbing the sediment, and creates a weathering of the rocks. Now, this stability of the weathering mineral is depends on the type of stability of rock depends on the type of rock, type of minerals which it contains. Olivine, olivine is the one which rapidly breaks down into clay mineral into iron oxide. Calcium-rich plagioclases they convert into clays like uranite, and pyroxene in amphibole wither into iron oxide clays. Now, moderately stable minerals are biotite and sodium-rich plagioclases. Similarly, the potassium-rich feldspars are also moderately rich compared to plagioclase feldspar. They all ultimately form clay minerals. The most stable mineral is resistant to weathering is muscovite as a mica and quartz, hematite and minerals. They are the ultimate quartz and hematite and are the ultimate product of the prolonged weathering. Now factors that control the weathering as a rock type. Rock type means whether it is a igneous rock, granitic rock, or basaltic rock, or a quartzite, or limestone, or a dolomite. What type of climate is there in the depositional area? Whether it is a temperate zone, whether it is a tropical zones, vegetation, whether there are lots of vegetation or there are no vegetation, or they are on the coastal area, vegetation on the coastal area or the river beds. So all those things, these rock type, climate, vegetation, all together they control the weathering. Now the particles that are produced by sedimentary process, they produce one type of plastic called terrigenous or plastic. As I already told you, they form by weathering of pre-existing rocks. For example, sandstone and shale. And chemical precipitates, the result of chemical activity on the surface water, form carbonate rocks and evaporize. And organic deposits like plant and skeleton matter, which includes the coal and mainly organic rich sediments. Now, terrigenous rocks in, are transported by gravity, water, and ice and end up as boulder, cobble, pebble, sand, and silt. And finally, they come to rest in basins or they call depressions, or we also call traps, either in the deserts or in rivers or in lakes or seas. This is what we call as a clastic sedimentation. The example is here, the conglomerates, sandstones, and shales are different composition and structure. Clastic composition include the mineralogical components are quartz, feldspar, mica, iron oxide, clay minerals, lithic fragments, organic debris, skeletal metal, mineral grains. The texture includes grain size, grain shape, sorting, entrapped faunas, and flora. The process of deposition, why does the sediment deposit? When it is being transported, they ultimately has to come to rest at some place. They come to rest only where the energy level is reduced. When the high energy level is reduced to low energy, and the change in turbulence, they lead to formation of horizontal layers, angular layers, and orthogenic deposits. Horizontal layers, when the sediments become very quiet, the energy level is very quiet, and then the sediments get layered into a small thin layers. When there is turbulence, it produces angular deposits, and orthogenic deposits form when there is quiet environment and there everything is deposited in a very, very wide depositional condition. This is an example of a conglomerate, a bedded conglomerate in in the river Ganga, where you can see the small pebbles are aligned and produces thin parallel lines, and there are also sometimes some of them are the cross beds, some of produce. Sediments get transformed into loose sediment become lithified. The word called lithic word has come from formation of rock. So lithification process, that is just by burial, the material get buried and overlying pressure makes it lithified and they become compacted and then they become the cemented and they form matrix formation. Now, in all these cases, there is a fluid which plays a role. The type of fluid that is moving around, that will create the type of compaction. And how type cementation is taking place, whether it is a quartz cement, or it is a calcitic cement, or it is a iron cement. So all these things, role of fluid is very important in this. The sediments get transformed by a process which we call as diagenesis. Diagenesis is a low temperature transformation of physical, chemical, and biological changes after deposition of sediment. In fact, to say there is no such sediment which has not been diagenetically altered. In the moment one grain comes in contact with another grain, the process of diagenesis starts right from there. So the interaction of grain and this solution, dissolution among the grains create a transformation, change in the composition. There are different types of diagenesis: syndiagenesis, anadiagenesis, epidiagenesis. The common sedimentary rocks which are formed here, which I already told you earlier: conglomerates, sandstone, shale, limestone, chalk, cochinas, algal stromatolites, dolomite, ironstones, carbonaceous rocks like coal, volcanoclastics, evaporites, and residual deposits. Non-clastic rocks, they are either formed as a chemical precipitate like limestone, which form directly from the ocean water or sea water, they form of limestone. Similarly, iron stones. On the other hand, the biochemical precipitates produces dolomite. Dolomite cannot form directly from the sediment. It is not a direct chemical process. It is mediated through a biochemical process. Similarly, the phosphate, phosphate rocks are also formed biologically mediated. Evaporates are formed by evaporation, high rate of evaporation, sunlight, and other thing. High rate of form gypsum, potash rock, rock salt. Then the organosedimentary rocks like coal, chalk, and there are other many deposits which are formed by algae and cyanobacteria. Find out the depositional environment. We infer by comparing the features seen in the ancient rocks with modern environmental domain. We go and see how the rivers are forming, how the sediments are forming in the modern river. We go and see and watch how the sediments are getting deposited in the coastal area, or we go and see in the mountains area how the sediments are being deposited there. And then we compare the features which are there to the older rocks, and then we interpret the deposition environment. So we can interpret a river formed by fluvial, formed by aeolian, formed by lake, by lacustrine, formed by glacial processes, by glacial, and formed by marine. And there are many subdivisions in marine: shallow marine, coastal marine, deep marine, and other things. Sedimentary environment, a comprehensive note is given here like that, which is a repetition of what I just told you. Fluvial by river, aeolian by wind, lacustrine by lake currents, glacial by ice, shallow marginal marine, continental shelf, beach, delta, tidal flat, deep marine, continental slope, deep ocean. These are the different type of environment in which sediments can form. A cartoon which I showed you, it is a sketch to show you, explain you the same thing what we have told you just now. The one which is formed in the upper side is a glacial. Alluvial fans are formed by the fluvial processes in the high slopes of the mountain. In the desertic area or in the flat area, aeolian dunes are formed. Lacustrines are formed. Evaporates are formed like that. Deltaic, tidal, beach, reef, shallow water marine, submarine fan, deep water marine, all these sedimentary This is a classical area starting from the positive area, which is the mountain area, and the negative area is the marine area. Finally, this is just to give you platform deposit, a carbonate factory, carbonates are found like that, where the sediments get trapped into the platform, and then they are either evaporated or biochemically mediated, and they form deposit. There are two types of platform deposit: rim platform and open rim platform, and they are also from ramps. And lastly, this is the final cartoon will tell you that all the processes what I just told you, the weathering and erosion starting from the mountain, transport and deposition by rivers and other processes, ocean transport and deposition by currents in the sea, and finally barrier and lithification in the sedimentary rock, which you call the post-lithification. So this summarizes the entire thing what I told you spoke to you in last few minutes. To summarize the whole lecture, I say sediments are loose, solid particles originating from breaking apart of older pre-existing rocks by weathering and erosion. Clasted rocks formed by accumulating particles of older rocks as clasts or mineral grains, including sand, gravel, and mud. Non-clastic sedimentary rocks formed by chemical reactions, precipitation of dissolved components, or from organic matter. The formation of sedimentary rocks involve weathering, erosion, transportation, and deposition. Physical and chemical weathering and weathering products. Production of the sediments, the kinds of sedimentary particles, heterogeneous plastic particles, transport and deposition environment, lithification and diagenesis, and leading to the common sedimentary rock. Thank you.